So I'll go to my sidebar and type Anaconda. There are two ways you can open Jupyter Notebook. Let me show you the first way. The first way is by opening Anaconda prompt. The second way is by opening Anaconda Navigator. So let me first show you with Anaconda prompt. So this is my prompt. Anaconda prompt is just like your normal CMD prompt that you have in your computer, right? So when it's ready, you just type Jupyter Notebook and then it will open Jupyter Notebook for you. Okay, so Jupyter Notebook. In this spelling, Jupyter Notebook. Right? Once you click enter, my computer is very slow, right? So it will take about 2-3 minutes to open. So Jupyter Notebooks and Google Colabs are the most popular tools that data scientists use. There's another tool called Spider that is found inside Anaconda. I'll show you once I use the second method to open it. Or let me just go and open Anaconda Navigator. So the second method is Anaconda Navigator. It will open in a web browser. So my Anaconda, this thing has worked. My Anaconda Navigator, you can see that it has opened the IPython file for me, right? The Anaconda Navigator is still loading. So when it's done loading, it's open another tab. So it has this. Can you see Jupyter? So this is my Jupyter notebook, right? My working directory is in my documents, right? I've gone to my documents to create a working directory. So I'm going to my working directory where I want to do all my analytics, right? So this Olive Analytics folder is where I want to do all my work, right? So I go to Olive Analytics, right? So I'm where I want to be, right? So I can open a new IPython file from here, right? So you come to this new. Once you click on new, it will show you, do you want to open the text file, a folder, a terminal, or a Python 3 notebook? So once I click on Python 3, it will open a new IPython file for me that I can write my code. So this is my Jupyter notebook. I can write anything, right? I can import NumPy as NP, right? I can import NumPy as NP, import NumPy, which is one of the libraries that we're looking at today, as NP, and do any goes to NP np.0. You can just perform any operation, right? So so that's for opening IPython files. That's for opening IPython files on Jupyter Notebook via Anaconda prompts. Now I don't know why my Anaconda Navigator did not open, but let me try it again. Okay, it has opened. So this is Anaconda Navigator. You can see that we have a lot of tools inside Anaconda Navigator. We have normal CMD prompt. We have data law for data analysis. We have IBM Watson Cloud. We have Jupyter Lab, which is just like Jupyter Notebook. This is our Jupyter Notebook. So we can open Jupyter Notebook from here. Well, don't disturb me. Just launch. Once you click on launch, it will launch. Okay, so let me click on launch. So Fulfill All Righteousness. So Spider is another IDE that looks like that is like Jupyter Notebook that has more tools that you can use. So we have lots of tools in Anaconda Navigator. It's not just Jupyter Notebook. So we have stop disturbing me now. We have PyCharm as well. We have VS Code, and then you have R Studio. So look at the R Studio that I told you to go and download that day. You can launch it from Anaconda Navigator. I hope that makes sense. Is that clear? So today let's go to Colab. So once again, this is how I open my Colab. I open my Colab from my Gmail. I went to my Google Drive, right? I went to my Google Drive, and once my Google Drive opened, I went to New, click on New, and then go to More, and then click on Google Collaboratory. It will open a new Google Colab for you, right? Then you can write your code inside Google Collaboratory. Have you opened the Google Colab file I sent to the group? So this is the second Jupyter Notebook I launched from my Anaconda Navigator. Have you guys opened the notebook I sent to the group? Yes, you can open it from your phone. All right, that's permitted. That's permitted. That's permitted. So today I wanted to take you guys. So it means that if you cannot write the code as I'm talking, then you need to, once you get your laptop back, run all of these codes yourself. I need you to write the code yourself, like everything that is in this presentation and the next one, because it's in 2 batches, right? So I need you to write the code, not copy and paste. I need to write it yourself. So Python programs can be written using any text editor. I can't hear you. Request what? So, oh, really? Okay, I'm coming. I think it's the same code, so you can try it again now. Okay, so try it again now. I've given you access. Let me know, did it work? All right. So I want to take you through Python syntax, right? This is not Python for data science yet. This is just basic Python syntax. We will use some of the elements of the Python syntax when we get to data science. But you first need to know, I think this is the reason why you were confused in my last class, because I was taking you through stuff where you're not familiar with Python syntax, right? So Python can be written using any text editor, blah, 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 blah. Yeah, of course, unlike other programming languages, there are no curly braces or semicolons in Python, right? Very important. It's a very high-level language, and instead of using curly braces, we use indentation. So let's just look at programming elements in Python. So these are the elements that help us to solve problems, right? So you can pick Python as a programming language, not just for data science, for just anything, for web development, for mobile development, for cloud and all of that stuff, data engineering, you can pick Python and use to solve just any problem once you understand the syntax. So let's go to the first, yeah. And then after this, we'll look at Python libraries, the very popular Python libraries that we have. The very popular Python libraries, which are NumPy, Pandas, and Matplot library. I hope we can finish this on time. So variables, now we have different type of variables in Python. So let me do this. So we have different type of variables in Python, right? We have integers. We have integers. An whole number like 10, for example, is an integer, right? Any long number that is more than 5, right, could be long, is called long. What's happening? Right? A float is in numbers in decimal places, right? Something like 10.0. Of course, a string is made of letters, right? So for example, my name is Essay. This is a string. A list is something that is inside, what do they call this now? A couple of operations. So for example, if I have 1, 2, 3, 4, 5, this is a list in Python, right? All of these are called objects. So this is the reason why Python is called, Python is one of the object-oriented programming languages that we have. Did I write that here? Why is my computer slow today? I should have written that here. Python is the called object-oriented programming. So let's look at an example of variable operations. So we use assignment operators to store variables, right? So for example, I've stored this value into A, and then I've stored this value into B. I can use these variables to carry out any operation. So for example, now I've written this function. Don't worry, I will explain functions later. I've written this function that says sum A and B for me, right? And then give me the sum of A and B, then print B. So let me run this and see what happens. Oh, this is slow. So A plus B obviously will give me 3 because I've summed, I've registered the value of 1 into A, and I've registered the value of 2 into B. There's another variable that we call data type that we call booleans, and booleans are just true or false. These are the only 2 types of boolean values that we have. So for example, if I decide I want to store this value into this variable, right? And I thought that we have only 2 types of booleans. It's either it's true or it's false. So let me print my boolean, then it will return true, right? If I do my boolean equals to false, and I print my boolean, obviously it will return false, right? So I've saved this value into this variable name. I hope it makes sense. Please, if there's any point that you don't understand, just call me back. But these are just very simple operations. So for example, string, right? I've saved this string value into this variable name, and then I can just print string, and then they will return this is a string, right? So obviously, let's look at more, right? I want to look at the type now. So h equals to 67 plus 0.90. Obviously, this is going to be a float. J equals to 66. Obviously, this is supposed to be an integer. and then Q equals to false. Obviously, this is supposed to be a Boolean. So if I print the type of H, print the type of J, and print the type of Q, Python will tell me, so can you see? So this is a float, this is an integer, and this is a Boolean, right? So very, very easy. I did something else, right? So I can say A, B, C, D, E. So A equals to 1, B equals to 4, C is true, which is a Boolean, D is pharmacist, right, which is a string, and then E is 90. So I can use this operation, this whose operation, tell me that, okay, you know what, tell me the data type of all of these numbers, and then the computer will tell me that, okay, A is an integer, B is a float, C is a Boolean, and C bool, right? D is a string, str, and then E is an integer, once again. And you can see H, J, and Q, right? So it will just give me the data type. That should be very, very simple. So that's all for variables and data types. Any question? No, now a number is an integer. A number can only be an integer or a float. A number cannot be inside an inverted comma in Python. But that's a brave question, Sha. So let me try it. So let me say F equals to, so let me put 78, right? Let's see, I think it will give us a string. So it comes out as a string. That's a brief question, right? So yeah, it gives us a string. So you can try it out yourself and see what it gives you. So of course, you know that this 78 now, you can't use it for a number operation because it's inside the string. So it's no longer a number, it's now a string. Right? Any other question? I don't understand that question. No, ask. Just rephrase it. Like, how do I? So for example, now we have this print is a command, right? I want to print the type of H. Is that what you're asking? There are certain things we call keywords in Python, right? So this print is a keyword that says print whatever I put inside this bracket, right? So for example, I want to return my Boolean. Like I want to return the value that I stored inside this variable named my Boolean. So I just print my Boolean. I can say, instead of print my Boolean, I can just say return my Boolean. Would that work? Right? I can just say return my Boolean instead of print my Boolean. It's the same thing, right? The print statement just, for example, I can say type, let's see if type my Boolean will work. Type into my Boolean, return the type. Can you see, it gives me bool. So I didn't even need to, at the end of the day, I didn't even need to use the print statement. Oh, sorry, the print keyword. So print is a keyword that we use in Python. Does that make sense? All right, so let's go to statements and expressions. Basic statements we use in Python now. So for example, print is a keyword or a statement. So we call it a statement here. The assignment statement is this equal to. So this equal to is an assignment operator, an assignment statement. It's very important in Python, right? What's wrong with you now? There's the input statement that we'll look at later. And then there's the import statement, right? So before we we did anything in Jupyter Notebook the last time, if you remember, we had to do, let me open this one. We have to import our libraries. So we use the import statement to do that. So can you see import pandas as PD, import numpy, import this, import that. So those are statements for you, right? And then Python expressions, once again. So we can have a normal equal to, which is called an assignment statement. We can have a post increment statement, which I'll show you an example of very soon, right? So import OS, import mass, import this. We use import to import modules and libraries, right? So do we have examples? So for example, this increment statement is just basically explaining that B this equal to 1 means B equals to B plus 1, right? It's very simple because there will be examples later where you see this post increment operator. We're going to use the post increment operator much later, right? So B, where you have a plus and equal to, is just saying for every time you have B, just update it by adding 1. So for example, if we have B equals to 37, B using B post increment equals to 1 is just saying B equals to 38 rather, right? So the answer is going to be 38, right? That's just taking you through statement and expressions. We are going to use statement and expressions much later. But when we start using them, I want you to just know that they are statements and their expression. My computer is very slow today. So the next thing is operations and maths. I mean, this is very, very basic. So we have arithmetic operations in Python. We have comparison operators. We have equal to. This means not equal to. Of course, greater than, less than. Greater than or equal to, less than or equal to, greater than or equal to. We have logical operators where we can use and, or, not. We have exponentiation, right? Where you can say 2 raised to the power of 4. We have execution. We use execution most times in CMD prompts, but I don't want to go into that. And then we have imports, right? So we have lots of math operations that we can use in Python. We can look for the absolute value of minus 7.5, which is 7.5. We can look for the sine, cosine. We can do lots of stuff in Python, right? So this is an example. So x equals to 5 plus 2, y equals to 9 minus 3, z equals to 6 times 5. You can see that when I printed them, we had the corresponding values. But modulo is something that you might not be familiar with. So modulo just means remainder. So modulo just means remainder. So for example, if we have 5 over 2, right? 5 modulo 2. So 5 modulo 2, 5 over 2. Five over 2 is going to give us 2.5, right? Right? So what we're looking for a modulo is this 1. Because if you take 2 out of 5, you have 2, and then the remainder is 1. So 1 is the answer of our modulo operation. So for example, again, if we have 7 over 3, right? Or let me say 7 over 2. 7 over 2 is going to give us what? Right? So 7 modulo 2, the answer is going to give us 1. So we can try that in Python. So let's go. So 5 modulo 2 gave us 1, right? So let me try 7 modulo 2. Can you see that the answer is 1 as well? That's just to explain modulo. So this is just a simple, so I stored this value into this variable. I stored this value into this variable. And I said this variable equals to A plus B, then print this variable. Simple. right? It's very simple. A plus B obviously will give me 166. Very simple. Let's look at comparison operators, right? Print 2 equals to less than 3. It will give us true or false, right? So let me give you another example. Print 8 equals to less than 3. 9 is less than 3. This obviously should be false. So if I run this, it will give me false here, right? Print type of C. What's C? I think we've stored C somewhere up here. I think we stored C somewhere up there, and it seems to be a Boolean. I don't have time. I want to finish this as soon as possible. Right? Print C. C is true. Let's look at this assignment operator. Print, so D equals to 3 equals to 4. Obviously, 3 is not equals to 4. So if you print D, it's going to give you false. So let me do another example. If you do D equals to 4, and then this assignment operator, this is an assignment operator, not necessarily equal to, right? So this should give me true now, right? So this should give me true. Again, I didn't need to put it into a variable. I could just say 3 equals to 3.0. This is an integer, and this is a float. If I run, it's going to give me true, right? Very, very straightforward. These are just simple operations that we do in Python. X equals to 4, Y equals to 9, Z equals to 8.3, R equals to -3. So let me see. Is X less than Y? Right? X is less than Y. Z is less than Y, right? And R equals to X. R equals to X, or R equals to X. So what we are doing is this and this or this equals to true. R is basically not equals to X here. But what happened is that this is a BODMAS operation thing. So this one took priority ahead of this. Usually this should be false. Right? That's why I returned true here. We did a div-mond to say what's the type of this. Do you remember when I taught you tuples in linear before we started linear regression? What did I call a tuple? Anyone? Can you remember? This is disconnected. And the meeting is still on now. Can anyone remember when I taught you tuples? So I said tuples are another list of real numbers. An ordered list of real numbers. If you go back to your notes, you'll see it. An ordered list of real numbers. Right? So this is a tuple, 34.6 is a list of real numbers. And then in another way, this is a 2 tuple because we just have 2 numbers. If we add 3, then it will be a 3 tuple. Right? So the type of G is a tuple, right? There's something we call indexing in Python. I don't want to go into indexing yet. Let me not go into indexing yet. This is the power operation. So this is just saying 2 raised to the power of 4. If you run it, you see that it's equal to 16, right? And instead of using POW, you can just randomly do 2 double asterisk 4. It will give you 16. Again, very simple operations, mathematics. Any question? Any question at this point? Don't worry about it. Don't worry about it. I will show you this one when we get to functions. Don't worry yourself. We're just basically doing operations, right? We're just basically saying, let me take this away. Is x less than y? True. Is x greater than y? You see that it will return false, right? So by just trying to show you basic mathematical operations, don't let me complicate issues, right? Do you have any question? Any question before I move into arrays? So today is just for basic Pythons, right? So arrays, when you see something like this in any programming language, right? Something like this, it could be in a square bracket, it could be in a normal bracket, it could be in curly braces, it could be in curly braces like this, right? They are called arrays. It could be in this one, it could be in normal brackets, right? It could be in normal brackets, and then it could be in square brackets. They are called arrays, right? So just note that anytime you see another list of numbers like this, it could not necessarily be a number, it could be strings. We'll see arrays when you get into NumPy in data science. We'll look at arrays. We use arrays a lot in Python, so of course you have to understand arrays. So what do we do with arrays? Is that arrays in basic Python are actually lists that contain mixed data types. So for example, look at this. This contains an integer, contains a string, contains a boolean, and contains a float. Right? So arrays in Python are lists that contains mixed data types. So we can use arrays to create lists, and lists can be created by defining it with a square brace. So for example, this is a list, right? Anytime you have data types inside square braces, we have lists. So let's look at list operations, right? You can create a list, an empty list, for example. Of course, creating an empty list will do you no good. But sometimes you can create an empty list when you want to write functions. Again, I'll show you that much later. You can create a list and put only integers inside the list. You can create a list and put different data types inside the list. So for example, A here, add 1, 2, 3, 4, 5. So let's print list. If you print list, we return 2, 4, 7, 9, obviously. If you print list 2, right, it will return what was inside. So we stored these values inside this variable name. So remember we did variable at the beginning. All these things are intertwined into each other. And then we store these values, these list values into A. So if you print A, it will give you 1, 2, 3, 4, 5. We can say what is the length of A. So the length of A is 5. So for example, let me add 2 more values, 6, 7. The length of A now will give me 7 because there are 7 values. So length A now will give me 7, right? So these are array operations. You can remove from the list. So for example, if I want to remove 2 from the list, I just do a.pop into 2. It will remove 2 and give me the rest. So let me run a.pop. Okay, good. This removed the, so what happens is that, let me just use this to explain indexing. So if you have 1, 2, 3, 4, 5. In Python, the first value is index 0, right? The second value is index 1. The third value is index 2. The fourth value is index 3. And the fifth value is index 4. So this just showing you that indexing starts from 0 in Python, not 1. So this is index 0. So when I remove 2, right, I remove the number in the second index, which was 3. That was the reason why a.pop2 removed the second index, which was 3 in this case. So for example, if I want to do, let me run this code again, and I want to remove the number in the 5th index, right? So if I want to do a.pop into 5, this is so we have 6 and 7. So this is index 5. And this is index 6. So if I remove the 5th index, it means 6 Lomajade. So let me go back and see if that works, right? Why is this thing slow? So you can see 6 is out. So this is how to remove a number from a list. We can create arrays, right? So I just created another list, another array. 0 to 6, I printed it with print G. Then it printed this. I can add a number to this by doing g.append, right? So if I want to add 9 to this list, right, I can do g.append, then I'll add 9 to it. So if I print G, you can see that they printed out my 9 inside the list as well. So these are lots of operations that you can do in Python. So I want you guys to go out and type. I want you to type this code. Don't do copy and paste. If you type the code, you are not doing me, you are doing yourself. Sorry, if you copy and paste the code, you are not doing me, right? We have multi-dimensional lists, right? So this is a list inside a list, right? So for example, this F, we had the first list in our square braces and the second list in the square braces. So if I print F1, which is supposed to be the first index. So for example, this was 1, 2, 3 inside the list, right? Then 3, 4, 5, 6 inside another list. So obviously this first list will be index 0, and then the second list will be index 1. That's what I did there. So by printing F1, it just returned 3, 4, 5. So if I print F0 now, of course, you know what it will return. It will return 0, 1, 2. Right? So you can have multiple lists inside a list. So for example, let me do why are you frustrating me today? You don't understand what? Yes, now that's what I'm explaining. That's what I'm just explaining now. Is the index 6, 7, 8. So for example, I have 3 lists inside this list, right? I need to put a comma. So I have 3 lists. So this is the first list. You can see it's in the square braces, then a comma. This is the second list, right? And this is the third list. So if I do index 0, like I've told you, this is the first index, which is index 0. This is index 1, and this is index 2. So if I do f into square bracket 0, it will give me the first index, right? If I do f into 1, for example, it will give me the second index. So for example, let me do f2. You see that it will give me 6, 7, 8. There are other operations we can do, right? And this one too is very important. So for this, for example, this is the list of 1 to 9. If I want to return 4 to 9, right? If I want to return 4 to 9, I'll use the index of k to return 4 to 9. And how do I do that? This is index 0. This is index 1. This is index 2. This is index 3. So I'll just do print k, right? Then open my square braces and do 3 and this. So we give me, so this is 0, 1, 2. So it will give me my index 3. So can you see? We return 4 to 9. Putting this before 3 will give us 1, 2, and 3. Right? So this is index. This is just saying return. So this is basically saying return index 0, 1, and 2. Does this array dimension operation make sense to you? If I want to return all the values inside K, I'll just do print K, and then I'll leave this like this. And so once I run it, will return all the values inside. If I want to return only 1, right? If I want to return only 1, what would I do? Can anyone try? I want this to be interactive. It looks like I'm talking too much. Print. Okay, I'm coming now. This then 0. Okay, let's try it. So you're almost there, but it was 1. So this is just giving me 1. See why I want this class to be interactive so that you understand what was happening. If I want to return only 9, let's say, what do I do? Let's say, if I want to return only 9, what do I do? What do I put before? What do I put here? Before and after, what number do I put here to return only 9 from this list? Oh, really? Oh, wow. So connect battery. Okay, let's just finish up. She'll catch up. Right. So if I want to return only line, what I'll just do is that this is index 0, 1, 2, 3, 4, 5, 6, 7. Right. So I'll just do 7, right? Or 8. Is this 7? Let's see. No, it should be 8. So 8 will return just 9. Right. So this is called slicing. It's called array slicing. It's called array slicing. So you are slicing out of the arrays to return something. This is going to be important too once you get to NumPy, right? So the next thing we're going to do is conditional operations, right? So of course, conditional operations is saying if this condition is satisfied, do this. This is very important in every programming language. Every programming language has conditions, right? So if this condition is satisfied, there's no programming or there's no data science without conditionals, right? So for example, look at this example. I said I stored my name into the variable name, right? Then I said if name equals to Diola, right? Print my name is plus name. Else print do something. I need to type this code out yourself when you get it on your laptop, right? So if I run this code, it's going to print my name is Diola. So let me change this Diola to Omolayo, for example. Right? The instruction is that if the name is Diola, print my name is Diola, or else print my name is print do something. So this is going to print what? Do something. I can also say print my name is Omolayo. Right? So this is all going to return what happened? ULY scanning string data. Okay. I've seen it. Thank you. Right. So this just prints my name is Omolayo. So conditional statements is just if and else. So we have if else, we have else, and we have elif, right? So let me show you how the rest of them are used. We're getting to the end of this class. So for example, now I've stored I've stored 4 into A, right? And let's say B equals to 9, right? So I'm going to give the computer an instruction now. I'm going to say if A is greater than B, don't forget this operator, right? This is the reason why stuffs are indented in Python. You see that once you click enter, you're going to indent your code. You're going to start your code from this line, right? So if A is greater than B, print A is greater than B. Let me remove this one. There's an extra yeah. So if A is greater than B, print A is greater than B. Elif, this is saying else if, right? Because we're using multiple conditional statements here. Else if A is less than B, print A is less than B. Else print A is equals to B. So because in this operation, we can only have 3 outcomes. We can only have A greater than B, A less than B, or A equals to B. So once you have 3 outcomes like this, the first one has to be if, the second one will be elif. That means else if. This is else if that was shortened by Python, right? So elif and then else. So let's look at it. Let's run this code. This will run A is less than B. Look at it. Let me do A equals to 9. So this will run A equals to B, right? This will run A is less than B. So we use conditional operations to tell the computer what to do. Very easy. This one too is very simple. We said name equals to, let's say Tumiche, for example. Let's say name equals to Tumiche. I'm now saying if name equals to Diola, print my name is plus name. My name is Diola. If name equals to Tunde. Okay, let me change this to Tumiche. If name equals to Tumiche, print my name equals to Tumiche. Else print I don't know your name. So obviously, if I say name equals to Tumiche, it's going to print my name is Tumiche. If I use something totally different that was not stored into this name variable, like Layo, for example, I'm going to say I don't know your name, right? So conditional statements are just that simple. The rest of the operations, I'll leave you to go and type that into the computer yourself, right? This one is just very straightforward, right? Enter maps. So let me run this one now. I said enter maps. So I use this input. If you remember up there when we talked about statements, I showed you input statements, right? So this input statement is used to collect an input into A, right? So if A is greater than or equals to 85, print this. If A is between 85 and 80, print A grade. Elif, you can use elif multiple times. So else if A is between this and this, print B grade, or this print print B minus grade. Else print below average. So let's run this code now. It will tell you to enter marks. Right, so let's say I scored 81, right? It returns A grade. So type this yourself and see, just very beautiful. Loop is also very important in Python, right? So loop, we use loop to, how do I explain it now? We use loop to carry out continuous operations, right? So if you want to carry out an operation and you want it to continue, you don't want it to stop, you're going to use a loop. So, but we have different types of loops in Python. we have for loops, we have while loops, we have continue loops, we have break, and we have else loops. So let's look at example of loops. So you'll see range operations in Python. So for example, this code says for I in range 0, 50, and 7, print I. So this range just basically says we are taking a range of 0 and 50. So look at the formula here. It's start, stop, and step. All right, so we are taking a range of 0 of integers between 0 and 50. But we want to take a step of 7. So if you print I, it will return all these numbers in a step of 7. So for example, let's change this step to and say 5. So what this will return is 0, 5, 10, till we get to 50. If you change this and say 2, it will return values between 0 and 50 in steps of 2. Why is this slow? Right, we return this in steps of 2. That's a for loop. So for loop is saying that for this in this, for I in range of values between 0 and 50, return all the values with a step of 2. So print I, so let me make it shorter. So let me do step of 8, for example. Let me start. Right, so these are numbers between 0 and 50 in step of 8. So let's look at another example of for loop. So for example, we have a list of our strings, right? So the value of this list, I've stored it inside A. So I'm saying for X in A, print X. Don't forget, this X could be anything. It could be I. So let me change it to I. So for I in A, print I. Let's say I'm not going to go back.